Hi friends, today we are going to see a short note, that is passivation. It's an important university short note. First of all, you have to write the key points properly, and then just you have to elaborate with the proper presentation so that you can get maximum marks. Let me explain. What is passivation? Passivation is nothing but corrosion resistance. So what alloys do require corrosion resistance the most? They are the base metal alloys. So base metal alloys majorly rely on chromium for corrosion resistance. So here the important thing is formation of chromium oxide. How does corrosion resistance takes place? So there is a thin layer of chromium oxide is formed over the alloy. So the diffusion of oxygen through the chromium oxide is prevented. So that this is how corrosion resistance takes place. And then you can see here that there is a point, that is solution hardening. Solution hardening is an added up point of chromium. So with the passivation, it also helps in solution hardening. When the alloy is formed initially, so alloy is basically a mixture of metals. So in the liquid state, the metal is mixed to form the alloy. So at that time, when chromium is added, it hardens the solution. So it plays a very important role. So the basic examples of base metal alloys are cobalt chromium, nickel chromium, nickel cobalt chromium. Nickel, it has its major role in stabilization. Nickel is considered to be allergic. It's not biocompatible. These are added up points. So basically now nickel is being replaced by titanium. Titanium is a very biocompatible metal, and it's a little bit economical. Not economical than nickel, but it's better economical. At the same time, it forms something called titanium oxide, so which helps again in passivation. Not up to the mark like chromium oxide, but still it helps. Titanium oxide, still it's better. And the minimum amount of chromium which is required for the passivation is 12%. So it's a very important point. Not less than 12 or not equal to 12. It has to be more than 12% of chromium. So that what happens is, then it forms the corrosion resistance better. At least it has to be more than just above 12% to form the layer for corrosion resistance. So the last point, yield strength. So chromium plays a major role in increasing the yield strength. So what is basically yield strength? Yield strength is very simple. So when the alloy goes beyond its proportional limit until it breaks until it goes to its ultimate tensile strength, it is yield strength. Whenever the alloy is within the proportional limit, whenever it's under a tension, if it's under a force, if I am giving a force on the alloy, there is a tension created, and if it's within the proportional limit, it's under the elastic region, so it comes to its normal position. When the tension is released, there is no changes in it. But when the tension is higher, when if consider that I am giving more force on the alloy, so it goes beyond the proportional limit. So what happens is it enters the yield strength, so it comes back with a deformity. When the tension is released, it comes back with a deformity. It doesn't comes to its normal position completely, so it's not completely elastic. I hope you understood the topic. I know this is a little bit tougher topic, but it's, if you write the key points and if you explain it properly with a good presentation, I think you will be scoring more marks. So if you have any doubts, kindly leave in the comment sections. Let me see you in the next video. Thank you so much.